Section 4.2, Writing Equations in Slope-Intercept Form. Our essential question is, how do you write an equation in slope-intercept form when you know the slope and one point on the line? Our vocab word is slope-intercept form. We've worked with slope-intercept form before. Slope-intercept form is y equals mx plus b. Remember that m represents the slope of the line and b represents the y-intercept, or where the line crosses the y-axis. Our first example says write an equation in slope-intercept form and graph. The point that's on the line is 2, -3, and the slope is 1/2. I'm going to teach you two different algebra methods to use for solving these types of equations. The first algebra method is going to be using point-slope form. Okay, if we take our point and plug it in for x1 and y1 and our slope 1/2, our equation would look like this. Y minus -3 equals 1/2 times x minus 2. Then I would need to simplify this. Y minus -3 would turn into a chunky plus, y plus 3, and I can distribute the 1/2 to get 1/2 x minus 1/2 times 2 is 1/2 times 2 over 1. You multiply straight across. 1 times 2 is 2. 2 times 1 is 2. So 2 divided by 2 is 1. And then I need to get my y by itself, so I would have to subtract 3 on both sides. So that would give me y equals 1/2 x minus 4. So my first algebra method is actually using point-slope form to get to my slope-intercept equation. So this is my slope-intercept equation for the line. Algebra method number 2 is going to be using slope-intercept form the entire time. This method is a little bit different over here. Now I'm going to use my point for x and y and my slope for m. So y is -3, my slope is 1/2, and x is 2. And I'm going to solve this equation to find my intercept. So simplifying 1/2 times 2, or 2 over 1, gives us 1. So -3 equals 1 plus b. I would subtract that 1 on both sides, cancel it out, and then my intercept is -4. Using this method requires me to then go back and plug in my slope and my intercept to get my equation. So my equation, y equals, the slope was 1/2 and the intercept -4. So I get the same equation either way. It's just that with the slope-intercept form, I'm going to have to go back and plug in my intercept and slope. So I'm finding b, then plug in m and b in the equation. So you can use whichever method you prefer. It doesn't matter to me at all. The graph, in order to draw the graph, I can graph by using the point and the slope or my slope-intercept equation. I'm just going to graph with slope-intercept. So my intercept is -4. My slope goes up 1 over 2, up 1 over 2, and then I can draw my line. So either algebra method works to get you to the correct answer. You could also graph the point and use the slope to draw the line and then try to find the equation for the line that way. Sometimes it works out nicely, other times it doesn't. Okay, another example. I'm going to use both algebra methods again. So point slope first. So x1 and y1 and m need to be plugged in my equation. Y minus 4 equals my slope times x minus x1. Y minus 4 equals -1 times x plus 3. Then I need to distribute my -1. So -1x and -1 times +3 is -3. Then I can add 4 on both sides. And y equals -1x plus 1. The second algebra method, remember, uses slope-intercept form the entire time. So I'm using the point that is given for x and y, because any point that is on your line can be substituted as a solution to your equation, can be substituted for x and y. My slope is m. So 4 equals my slope times x plus b. -1 times -3 is +3, and then I have to get rid of that +3 by subtracting it. 4 minus 3 is 1. My intercept is 1. Now make sure you go back to this equation and plug in your slope and your intercept. The slope was given, it's -1. The intercept I solved for, +1. Final answer. So I start at my intercept of 1, and then I use my slope. My slope is -1, so that means I'm going down 1 over 1, down 1 over 1, and then I can draw my line. So negative slopes, you go downhill. Okay, our next example is a word problem. Joe needs to have his car repaired. The parts will cost $145. And the mechanic charges $60 an hour for labor. Write an equation to represent the total cost C for H hours of labor. Okay, so my total cost C is going to be equal to the parts plus the labor, $60 per hour, so $60 times H. What's important here is that you recognize where to put your variable. The $145 happens only once. That's like our starting point. It's kind of like our intercept. So the parts happen once. The hours, the $60 an hour for the mechanic, we don't know how many hours it's going to take, so that's where the variable goes. That's what's happening for it's happening more than once. Like it could be 2 hours, 3 hours, 4 hours. So that's where the variable needs to be on the $60 per hour. The per, like the slash per hour, that's a sign that that's where your variable would go, the word per. Okay, now in part 2, if Joe paid $355, how many hours did it take the mechanic to fix his car? So for part B, we know the cost is $355. So that goes on the left-hand side, and then we need to solve the equation to find out how many hours it takes. So I can subtract the parts on both sides. And that leaves me with $210. So if I divide by 60 on both sides, 210 divided by 60, 60 times 3 is 180. 60 times 5 is 300. So 3.5 hours is how long it took the mechanic to fix his car. Our last example, Grant is ordering tickets for a hockey game. There's a processing fee for each order, and the tickets are $45 each. Grant ordered 6 tickets, and the cost was $285. Number 1 says how much was the processing fee? And number 2, write a linear equation to represent the total cost C for T tickets. Okay, so the tickets are $45 each. And he ordered 6 tickets. And he paid $285. Okay, so let's think about this. If I multiply 45 times 6, because he got 6 tickets and they're $45 each. 45 times 6, so this would be 30, so that would be $270. $270, but he paid $285. So that tells me that the processing fee is $15. $15. So what I did was I said, well, we've got $45 per ticket times 6 tickets, plus a processing fee. Has to add up to $285 that he paid. So multiplying these together, I got 270 plus the processing fee equals 285, and then I just subtracted. So there was $15 that he paid that was extra, because the tickets we knew were $45 each. So now for part B, if we write a linear equation to represent the total cost, so I would say C equals 45 T, because it's $45 per ticket, plus $15 for the processing fee. So that's a general equation that you could use for any amount of tickets, now that we know the processing fee was $15. You should be able to write a summary now that answers your essential question.